Hello friends, today I am going to talk about organic chemistry and in that the topic I will discuss here is hyperconjugation. Here you can see I put the notes, so upon explaining this you can understand better. In here hyperconjugation is also called sigma bond delocalization. Also it is also called as number of no bond resonance or Baker-Nathan effect. Here you can see the definition: delocalization of sigma electron of carbon hydrogen bond of an alkyl group directly attached to an atom of unsaturated systems or to an atom with unset p orbital. So you can see the examples down. When here you can see this is sp2 carbon adjacent to that there is a carbon and the number of hydrogen attached to that, it will be called as alpha hydrogen. Okay, similarly see here sp2 and this is alpha hydrogen. So other also you can see this is not in syllabus actually, and this if this all are attached to the carbon, you have to only look that carbon which is attached to the sp2 carbon. So if these all are attached to your coming carbons, then you can calculate the alpha hydrogen of the another attached carbon. Like here you can see here a benzene ring is attached, and the adjacent to that here this carbon has 3 hydrogen which is sp3. Here alpha hydrogen will be 3. Similarly here you can see this is sp2. If radical will be also present like this, if radical is there, then also it is sp2. You can see sp2. So it is sp2. If sp2 is attached with your adjacent carbon, so it has 3 hydrogen, it will be called as alpha hydrogen. In here you will see a radical. If radical will be also present, then also if vacant orbital is there, vacant p, then also it is called as sp2. In here it will not consider in your hybridization, so it is radical sp2. sp2 is attached with your carbon which is having hydrogen, so it will be called as alpha hydrogen. Next, coming to the topic, hyperconjugation is of two types: sigma p conjugation and sigma pi conjugation. Sigma p conjugation, carbocation. So you will see here it is again the same explanation. This is a carbocation, actually carbocation which is having sp2 carbon. So attached to that there is a alpha hydrogen. So this video is giving you the best preference how we will select the alpha hydrogen and hyperconjugation questions. So next, see here, in this example you will see here is no hyperconjugation. Why? Because it is attached to sp3 carbon. You can see the hybridization sp2 sp3 carbon or nitrogen, anything, then it will be having no hyperconjugation, although it is having hydrogen attached to that carbon, but it will be not considered because the attached part should be sp2. Same. Next you will see carbon free radical. Here you will see the explanation. Actually it is a orbital diagram. It is having vacant. It is sp2, and this is alpha carbon, and this will be called as alpha hydrogen. Hyperconjugation in carbocation hyperconjugation, in carbocation you will see this is actually explanation of sigma p conjugation. So this is NCRT diagram, actually vacant, this explaining the orbital, how the hyperconjugation take place between vacant and filled, so this is explained actually by MOT. When bond is formed, VBT doesn't explain much more about the hyperconjugation, but MOT will explain you about the hyperconjugation. Here you will see, you will be not sure just by VBT that this hyperconjugation is going to happen or not. But in MOT says that when this filled and vacant, they are in combination. So what will happen, that this filled and this vacant one will contribute to the bond orbital. So energy will decrease and the bond will form, stable. They will become stable and the bond will form. As a result, you will see this type of structure. Means this will exist, means hyperconjugation is taking place. But in here you will see this is a field, and this is also a field. In case of this, no hyperconjugation will take place. Both of them field will also contribute to, and they will give the bond order 0, not exist. This all are called hyperconjugation. Thank you.